Welcome to this video on computer vision, where we will explore its fundamentals and applications. This presentation dives into the major tasks, technical methods, and challenges in this exciting field. Here's an outline of what we will cover today. First, we will define computer vision and discuss its evolution. Then, we will explore the key tasks involved and their real-world applications. Next, we will look into convolutional neural networks and how they drive vision models. After that, we will discuss the limitations and ethical challenges of computer vision. Finally, we will wrap up by demonstrating Python libraries used for computer vision tasks. Computer vision involves analyzing images and videos to extract meaningful insights. It's widely used in applications like facial recognition, self-driving cars, and generating new visuals. Early breakthroughs include recognizing handwritten digits with the MNIST database. Today, it powers real-time image analysis and high-tech solutions. Key tasks in computer vision include image classification, which categorizes images into predefined labels. Image segmentation goes further by grouping pixels into distinct regions. Object detection identifies and localizes objects in an image. Image captioning generates textual descriptions for images. Text-to-image generation creates visuals from textual prompts, while image-to-image generation transforms one image into another based on specific inputs. Convolutional neural networks, or CNNs, are the backbone of modern computer vision. They use convolution layers to detect features like edges, textures, and patterns in images. Pooling layers reduce the dimensionality of data while retaining essential details. After processing, the data is flattened and passed into dense layers for tasks like classification or prediction. Despite its potential, computer vision faces several limitations. It requires large amounts of labeled data and significant computational resources. Models can be opaque, making their decisions difficult to interpret. Bias in training data can lead to unfair outcomes, affecting the reliability of results. Computer vision has applications across diverse industries. In healthcare, it's used to diagnose diseases from medical images. In agriculture, it monitors crops and livestock to enhance productivity. Autonomous vehicles use computer vision to detect obstacles and understand road conditions. In creative fields, AI generates artwork and edits visuals, enabling new forms of creativity. Python libraries simplify implementing computer vision tasks. Torchvision integrates with PyTorch for training and deploying models. KerasCV, built on TensorFlow, provides powerful tools for image analysis. The Transformers library supports tasks like image captioning using pre-trained models. To summarize, computer vision extracts insights from images and videos for numerous applications. Tasks like classification, segmentation, and object detection are pivotal in this field. CNNs play a crucial role in enabling these capabilities. However, ethical considerations and data requirements remain critical challenges. Python libraries make advanced techniques accessible to developers and researchers. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.